Students, this is lesson U5A06a. By the end of the lesson, you should be able to say, I can apply sine, cosine, tangent to solve for sides if given one side and an angle other than 90. Alright, so this is a summary of what we had talked about in lesson U5A05b, as well as similar concepts in U5A05a. Keep in mind, all of these concepts involving sine, cosine, and tangent are only applicable when we're dealing with right triangles. Any other kind of triangles, these trig ratios are not applicable. Let's take a look. So in this, what we're doing here, okay, is rather than solving for the side length of a given triangle, here what I'm asking you to do is to find the ratio of sides. So let's take a look at this, okay? So you're given a triangle, which is a 3, 4, 5 triangle, and we know this inherently, this is a right triangle because this is a Pythagorean triple. And we also, we don't know what the angles are, but that's not the point of this exercise here. The point of the exercise is to find out what are these ratios. And this is the key to understanding. So sine of A, okay, A being the angle here, so this is angle A. So sine of angle A, what I'm asking you to do is to find out what that ratio is. If you recall, again, from the previous video, okay, what you're evaluating here is a ratio of sides. So what ratio of sides are we referring to? We're referring to the side that's opposite of angle A divided by the hypotenuse. So what exactly is that? Well, I immediately see here the side opposite of angle A, that's side 4. And the hypotenuse, that's along the side of the right triangle, that's going to be 5. Moving on, we're going to find out what is the ratio for cosine of A. So keep in mind this is a ratio, right? So it's the ratio of sides that is adjacent to angle A over the hypotenuse. So this side here is adjacent to, and the side that is the hypotenuse is once again 5. So this is 3 over 5. I encourage you to pause the video now to see if you can figure out the remaining ratios that are left on this slide. Go ahead. So hopefully you guys had some time to think about this. So the ratio of tangent of A, that's 4/3. And then sine of B, that is going to be 3/5. Cosine of B is 4/5. Tangent of B is going to be 3/4. Sine of A, if I look at the triangle below, sine of A is 5 over 13. Cosine of A is 12 over 13. And tangent of A is 5 over 12. Moving on, I'm looking at sine of B. So sine of B, the side opposite of B is 12. The hypotenuse is 13. Cosine of B, I'm looking at the side that's adjacent to angle B, and that's side length of 5. And the hypotenuse is 13. And lastly, the ratio between opposite to adjacent, that is 12 over 5. All right, so find the approximate side lengths of the triangle, round your answers to the nearest thousandths. Okay, so we need to find out all the various side lengths here. So I noticed that this is 30 degrees, right? So we're going to actually use our calculator for this because we're going to find out what the actual numerical, like decimal values are of the various side lengths. So pause the video to see if you can figure this out. Hopefully you guys had some time to think about this. If we were to set this up, okay, I know 5 is adjacent to 30 degrees. I also know W is opposite of 30 degrees, and X is the hypotenuse. So therefore, I know cosine of 30 is equal to 5 over X. But if I were to enter cosine of 30 into the calculator, right, and if you're wondering how I got this, let's just jump right to the calculator real quickly. So I have my calculator here, When you're entering these values into your calculator, I'm going to hit mode just to make sure that you're in the correct setting right now. So if you look at line 3, okay, we have radian setting and degree setting. Right now, everyone should be operating in degree setting. So you're going to highlight degree and press enter if it's not already there, okay? But by default, your calculator is actually set to radian settings, which is what math engineers use more of, okay, over degrees. We'll have a longer discussion of what's the difference between the two, but that's not for this video right now. So make sure your calculator setting is set to degree. I am going to go over here. You're going to press cosine. Where exactly is cosine? Cosine is located right here, okay? So I'm going to hit cosine, and I'm going to punch in 30 degrees. And what we have is 0.866, 0.25. This is actually an irrational number. It goes on forever, and and the decimals never ever repeat itself. But that's the decimal value. It's 0.866. I take this, okay, and I replace cosine 30 with 0.866, and that's approximately equal to 5 over x. I can, if I wanted to, get the exact value of this, but that's not the point of this exercise because I want to get a decimal value out of this. So we're going to continue with this. We're going to isolate x by cross multiplying. So I get x times 0.866 is equal to 5. Divide by both sides by 0.866. So 5 divided by 0.866, that comes out to approximately 5.774. So we wanted to round our answers to the nearest thousands, and that's exactly what it is. To the thousands is to 3 decimal places. We're going to, again, try to figure out what is side length W now, since x was the hypotenuse. So to do that, okay, we're going to, side W, okay, is this side right here. This is opposite, and 5 is adjacent. We're going to use tangent of 30. So tangent of 30 is equal to W over 5, and we're going to, again, figure out what tangent of 30 is by using our calculator. So if I take our calculator and run it through, okay, I'm going to hit tangent of 30 and press enter. I end up with 0.57735, so on. I'm going to copy that number over here. And what I'll end up with is 2.887. So again, I replace 0.5, I replace tangent of 30 with 0.5773, and I punch that in, and I will end up with 2.887. So actually, you can do this all in one step like I did here when I made the slides, okay? You do not have to copy down the decimal values. You can just enter everything in all at once, too. All right, so we're moving on to other angle measures here that are not 30, 60, 90 and 45, 45, 90. We treat this all the same way. So again, we need to solve for all the other side lengths here. We're told that side length B here, or the hypotenuse, is 3. So again, 3 is a hypotenuse. Side length A is adjacent to 70, and side length C is opposite of 70. So if I were to figure out what side length C is, that's opposite, I'm going to use sine because I know the hypotenuse here. So sine of 70 is equal to C over 3. I again punch in sine of 70 into the calculator. Or I can also multiply both sides by 3 first to get 3 sine 70. And I can punch all this in at once. So I can do 3 times sine 70 is 2.819. Similarly, I can solve for side length A. A is adjacent to, right? So it's going to be cosine. Cosine of 70 is equal to A over 3. I want to multiply both sides by 3 to find out what is A. So A is equal to 3 cosine of 70. Punch this into the calculator. I end up with 1.026. Pause the video to see if you can solve this on your own. Hopefully you guys had some time to think about this. So now what I'm going to do is I'm going to, again, find out what the hypotenuse as well as the side adjacent to 10 degrees is. Okay. So I know that 7 is the opposite side of 10 degrees. I also know that side length I is the adjacent side and side length J is the hypotenuse. So therefore I can say sine of 10 degrees is equal to 7 over J. Cross multiply. and then divide by sine of 10 degrees. And I can enter this into my calculator all in one step. So 7 divided by sine of 10. I can punch that in. 7 divided by sine of 10 degrees. This can be done all in one step. So I get 40.311. Similarly, I can solve for the other side length by using tangent of 10 degrees because I have the opposite side and I don't know the adjacent side. I'm going to cross multiply both sides by I and then divide both sides by tangent of 10. So therefore, 7 divided by tangent 10 is 39.699. That's it.